Alright guys, welcome to another episode of Bran Academy. As always, my name is Bran. I'm Mr. Wynn's twin brother. And today, we'll be on chapter 10-2. But I'm just going to do a little throwback real quick, okay? Look at this image real quick. Which side is the largest? Okay? So, this is 45 degrees, this is 40. Total is 85. Which means this remaining angle has to be 95 degrees. So once you find that, which side is the largest? It would have to be the one opposite the largest angle. So the largest side is BC. Okay? I'll make a connection to today's lesson soon. Next example. Which angle is the largest? Okay? So again, the angle that's opposite the largest side will be the largest angle. Okay? So in this case, just like a reminder, like the more something opens up, the larger the side will be, right? If it opens up smallly, it's a small side. Okay, similar here, check this out. For a circle, which is what we're going to get to for chapter 10, right? If this angle is bigger, this arc length is bigger, okay? Arc length. Okay, this right here is going to be bigger than this arc length, right? Okay, so we're going to talk more about that. Essentially, bigger the angle, bigger the arc length. Okay, so now we're not just dealing with, straight segments, we'll be dealing with arc length, okay? And this is specifically for circles, okay? So chapter 10 is all about circles, all right? Chapter 10-2, we're skipping 10-1, we're not really skipping it. 10-1 is just a review of circumference and area of a circle. And I'm sure we already know that. 2 pi r, and then area is pi r squared. Okay? So for 10-2, it's a lot of definitions, okay? So I'm going to really speed through this. Angles and arc lengths. A central angle, the word central, right, is at the center, is an angle whose vertex is at the center of a circle and whose sides are radii. Radii is just plural for radius, okay? Don't ask me why. I don't know. It's probably a Greek thing. So radii, okay, so boom, this right here, central angle, formed by radii EG and EF. Please make sure you fill this in. Your major arc and your minor arc, okay, is going to be what your central angle forms. Okay, so for example, GF, this right here should be like a curve, okay? So this symbol is literally it's just a curve. Whoa. Go away. This GF, this symbolizes rainbow, right? It's just arc length. Okay, that's what that notation is. So GF is what we call a minor arc. Okay, minor arc. I'll highlight these. GF, boom, minor arc. Okay. CHG, arc, CHG. Again, this arc here is a little rainbow. Okay. CHG, CHG. Okay, so we're going to just follow along, okay? Trace it out. Start with C, boom, go to H, go to G. This is what we call a major arc. Major key. Okay, a major arc. And specifically these definitions, a major arc is greater than 180 degrees. And a minor arc is less than 180 degrees. Okay. So angle GEF was GEF. Boom, right here. GEF. This angle is what we call a central angle. Make it purple. Central angle. Right? Okay, just some definitions. Okay, we're going to talk about it more. You might be wondering, oh, GF? When you say GF, right? Could there technically be two GFs? Because here's one right here. Okay, pay attention. It's important. We got this to be GF, right here. Boom. But can this be GF as well? GF. Right? Can that technically be a GF? The answer, in short, is just going to be no. Oh, shoot. Too big. The answer is no, okay? When we talk about a minor arc, okay, I'm going to spoil it a bit. In this box here, when we talk about a minor arc, it always has 2 points, okay? 2 points. As in GF, that is just 2 points, so it's going to be a minor arc. To designate a major arc, we're going to use 3 points, okay? So keep that in mind there. Anytime you just see 2 letters, aka 2 points, that is a minor arc. Anytime you see 3 letters, that would be a major arc. Okay? So don't trick yourself. If you just see GF, just think simple. Boom, GF is always a minor arc if it's just 2 points or 2 letters. Okay, next up, some properties. The sum of the measure of the central angle of a circle is, you add this all up, add up all these central angles, it forms a circle, which is 360 degrees. So that's what this is doing here, all those angles. Okay, add up all those central angles, it equals 360. Left side is a property name. The right side is your example, okay? Just keep that in mind here. Let's check out the next property. 2 minor arcs, okay? 2 minor arcs are congruent if and only if their corresponding central angles are congruent. Okay, let's see what this means here. This is saying arc CF, okay? Arc CF, what is that? Okay, I'm going to erase this, okay? I'm just going to erase this just so we can have a easier visual. CF, boom. Arc CF and arc FG, where's FG? Boom. These two can only be congruent if angle CEF is congruent to angle FEG. FEG. Okay? So again, the central angle and the arc length, they correspond to each other. Okay? Next property, the measure of an arc formed by 2 adjacent arcs. Remember, adjacent means next to. Okay, so if they're next to each other, the sum of the measures, the measure of an arc formed by 2 adjacent arcs is the sum of the measure of the 2 arcs. Basically just saying addition property works for arcs. Okay, so CF, okay, CF and FG, if you combine that, that's the same as the measurement of arc CG. Okay, don't forget the arc symbol. The measurement of arc CG. Okay. Scrolling down. Okay, again, minor arcs. Okay, they're always formed by 2 points. And it's always equal to the angle. So the measurement of this arc, okay, the measurement of arc AB is whatever angle this is. So angle X degrees. Okay. So basically, if angle ACB, if this equals, let's say, 60 degrees, if that is true, then arc AB, measurement of arc AB, this arc right here, is 60 degrees. Okay, they always correspond. Okay, central angle and the arc that it forms are always congruent. Okay. And some tricky maneuvers for major arc here. Let's look at right here. ADB, okay, it's already in red right here, ADB. Okay, so how can I find the measure of that arc? Well, if you know this is X degrees here, then all you need to do is do 360 minus X, okay, to find the arc length for ADB, okay? So you're basically using the property of a circle, which is 360 degrees, to help you find the arc length. So you might be wondering, okay, minor arc is less than 180. Major arc is greater than 180. Well, a perfect semicircle is when it is equal to 180. Okay, aka ADB is equal to 180 degrees. Okay, so you can say that, or you can even say measurement of AB is 180 degrees. Okay, because whether you go this way, boom, or the other way, they're both forming that semicircle, which is 180 degrees. All right, let's do some examples here. So again, something you want to highlight, the central angle is equal to the arc measure, okay? The arc measure, boom, okay? All right, so the measurement, so BD, reading the directions, BD and AC are diameters of circle O. Identify the arc as a major arc, a minor arc, or a semicircle, then find its measure. Okay, I'll do number 1 real quick. The measurement of arc BA. Okay, this arc, it's easy. What's the center angle? Boom, it's 44, which means this is 44 degrees. And what type of arc is it? It's going to be a minor arc, okay? Pause the video here. Okay, please do 2, 3, 4, 5 on your own. Okay, and then check your answers right after, okay? Alright guys, so please check your answers real quick right here. Just a little explanation. Okay, CD, that's pretty easy. Vertex angles, right? These two, boom, vertex angles. So CD is 44 degrees. If the angle is 44, that's the same as the arc measure, okay? BCD, you can tell 3 points, okay, major arc, but in this case, BCD perfectly fits out for what? BCD, boom, is a semicircle, okay, that's 180 degrees. BC, okay, BC is a bit tricky here, boom, this is BC. So if you think about it, look at AC, I'm gonna highlight it here. Boom, look at AC. AC is a perfect semicircle, which means half of it is 180 degrees in blue. If this is 44, the remaining angle right here is 136. So that makes this a minor arc for 136 degrees. Make sure you put degrees. That's kind of like your units. Okay, and then ACB. Where's ACB at? Boom. A, C, B. All of that. Boom. You basically take 360 minus 44. Gives you 316 degrees. Okay. All right, forward to the back side. Arc length. Okay, now it gets tricky here. It gets a little bit tricky. We just talked about arc measure. Okay, please write this down, highlight it. This is where people get confused a bit. Arc measure, you're talking about the degree. Okay, the angle, the degree. Now we're talking about arc length. Okay, when we talk about arc length, this is when we're talking about your units. Okay, like feet, centimeters, meters, or inches. Okay, so arc measure, boom, we're talking about degrees. Arc length, we're talking about these units. Okay, so very different things, but they sound very similar. Okay, so an arc length, okay, look at this circle, boom, the arc length. Okay, this is just the circumference, right? When we talk about the circumference, right, the perimeter of a circle. So if you think about it, the circumference is 2 pi r. Okay, we know that, the whole circumference. But now for arc length, okay, arc length, we're gonna use L, okay, for arc length, okay, L. Okay, so arc length L, if I just want to find a piece of it, right, this piece, so not the whole thing, okay, we need to take a fraction of it. So a fraction of 360 degrees times 2 pi r. Boom. This here is your formula for arc length, okay? Right there. Okay, 2 pi r. You could simplify this, so you could simplify it, right? The 360 and the 2 simplify, so x equals 180 over, or not, x equals x over 180 times pi r. So you could do that, okay? But instead of memorizing a new formula, I'd rather you guys just conceptually, you just have it, right? Because you know this formula, 2 pi r, and now you know for arc length, you're just taking a piece of it. So a piece of it is x over 360, right? A circle. So if you really want to, you can memorize this, but for one, I kind of just do this because it just conceptually fits in my brain easier, but both are fine. Okay, let's do one example. Okay, find the length of AB. Oh, yeah, the length of arc AB. Okay, it says length, right? So we're not talking about degrees right now. We're talking about this, okay? So keep that in mind. Okay, the length of arc AB using the following equation. Again, we know that equation already. It is x over 360 times 2 pi r. So we need to know x right here. Oh, I should have let you guys know that. Well, x equals a degree. Okay, that's the angle. So in this case, for AB, what's the angle? What's the arc length? This here is 135 degrees, right? Since the central angle is 135, right, the arc measure is 135. So it'd be 135 over 360 times 2 pi. What's my radius? Radius is 8. Boom, you can do some math magic here. Now you can make this 180. Does it work out? So yeah, something like that. So this is approximately 6 pi. 6 pi rounds to the nearest hundreds. Ooh, hundreds now. Inches, okay, boom. So that is the measure of this arc, right? So keep this in mind, okay? The measurement of arc AB, the measurement is what? 135 degrees, okay? That's the measurement. Now, what is the length of arc AB? Okay, the length of arc AB, you just say AB, boom. This is the length of arc AB. Oops, sorry. Do that. Now that is 18.85 inches, okay? Everybody look at these two right now, okay? Distinguish. Why are they different? Okay, this has the M, okay, measurement has the M for measurement of the arc. If it doesn't have anything, this is just length of arc AB. Okay, so understand those two differences. Okay, next video is just the examples now, okay? We're just gonna do 2, 4, 6, 8. So please check out the next video.